Welcome to our first in what will be mini videos called Spotlight on Statistics. This one starts with the basics. We're just going to learn the descriptive statistics and then how to create histograms from those. All right, what are the descriptive statistics? Well, first of all, what is a statistic? A statistic is basically a measurement that we get from a sample that we then kind of generalize and hope it's the same in a population. If we take a measurement from a population, we call it a parameter. But a statistic just means that the number was based off of a sample of data that we can hope to generalize to the larger population. For example, the US Census estimated the population of the United States to be this big number, 308 million, of which 50.8% were female. Now, some people would claim that that number is a parameter, but in truth, it really still is a statistic because even though it's a census and a census is supposed to collect data from everybody, it is impossible to collect data from everybody in the United States. For one thing, it takes so much time that even if you were able to get every single person to fill out the survey, by the time you were done, there were people who have died and people who have been born that weren't part of it, so it would be inaccurate. I mean, it would be impossible. You would have to instantaneously get everybody to fill out the survey, and then the data would only be valid for that instant. And the next day, people have been born and people have died, and the numbers would be different. Now, oftentimes they will consider these numbers to be parameters, that they are as close as we're going to get to the whole thing, so we'll just assume that the population of the entire United States is 50.8% female, but in truth, it really is a statistic, and we're hoping that we can generalize it to the larger population because that population, in fact, is different than what we got from the census. Okay, there are a lot of functions that play very important roles in statistics because the 8 basic descriptive statistics are all based on functions. The mean, or what a lot of people call the average. The median is the middle of your data. So you have to order your data from smallest to biggest, and then you find the number that is directly in the middle of it. That's the median. You know, if you think about when you drive down the highway, the median is that big cement barrier that goes down the middle that you slam into at 50 miles per hour because you were texting on your phone. Well, that goes down the middle of the highway, and the median is in the middle of your data. The mode is the most frequent data value in your set of data. So it has to have a frequency that is higher than at least one other piece of data. So if, for instance, you had the numbers 1, 2, 3, 4, there's no mode there because they're all the same. If you had 1, 2, 3, 4, 4, then 4 would be the mode. If you had 1, 2, 3, 3, 4, 4, then both 3 and 4 would be the mode because they're, both of equal frequency of 2. If you had 1, 1, 2, 2, 3, 3, 4, 4, you would be back to no mode because now they all showed up twice and they didn't beat out anybody, right? But if you had 1, 1, 2, 2, 3, 3, 4, 4, and then 5, now all of a sudden 1, 2, 3, and 4 would all be the mode because they all had frequency of 2 and 5 only had frequency of 1. Okay, so the mode just has to be the most frequent. You can have a tie, but you have to at least be more frequent than something else in your data. So if they all have equal frequency, there is no mode. Standard deviation is a very complicated formula that basically measures how spread out your data is. If you want to think about it, it's kind of the average distance from the mean. So if you take every single number and calculate how far it is away from the mean, away from the average, and then you average all of those distances, right? Some of them are bigger, some of them are smaller. But if you think about, okay, if it's 2 bigger, that's still a distance of 2. If it's 2 smaller, that's still a distance of 2. If you take the average of all those distances, that's basically what the standard deviation is. That's not exactly what the formula does, but that's a pretty close approximation that we can wrap our heads around. So that's kind of what the standard deviation describes. Everybody knows what the max is. Everybody knows what the min is, right? Maximum and minimum values. The range is simply the difference between those two. So if you take the max minus the min, that's the range. So it's basically how far apart are those two values. And then count is one that you don't see often. You don't see it normally listed as a descriptive statistic, but it's basically just how many pieces of data do you have in your data set. Okay, now with that in mind, we can now calculate all these things in Excel. First, let's take a look at some of the formulas that we would do by hand, right? The average is simply you add up all of your x sub i's, where x sub I means each of your data values, right? So the third data value would be x sub 3. The I is just the ith data value. So this little symbol here is the Greek letter sigma, which means to sum up, which means to add up. So you add up all the x's and divide by capital N, which is your number of things in your data set. Sometimes it's also a lowercase n. We normally reserve capital N for populations and little n for samples, but it depends on the book. This book tends to like capital N. N is n, really. Number of things. And we all know how to do an average. You add them all up, divide by how many they are, and then we call that x bar. X bar is the symbol that we use for the mean when we're talking about a sample. If we're talking about a population, then we use a symbol, a Greek letter for that, right? And those Greek letters are always reserved for population. So anytime we're dealing with a population, we're dealing with a Greek letter, and anytime we're dealing with a sample, we're dealing with usually just regular old letters. All right, keep that in mind. Okay, standard deviation, like I said, very complicated, messy formula. You don't want to try and do this one by hand. It's very difficult. You have to take each data value, subtract the mean from it, take that thing, square it, add all those together, divide by n minus 1. So you can see how we added a bunch of things, divided by how many there were, kind of, right? So that seems like it's an average. We squared each of these things because some of them are positive and some of them are negative. And then at the end, we square root it, which undoes the square. So you see how, in essence, we're pretty much getting an average. It is quite different than just the average, but it's pretty close to it enough that that helps us understand what it's doing. All right, let's see if we can calculate some of these with our data set. So go to your data sets and open up the CAT scores worksheet, which is 98 student scores on a critical thinking assessment test called a CAT. And let's see if we can calculate these 8 descriptive statistics on that. All right, when we have to calculate statistics in Excel, we need to tell it on what values. So like for instance, if we wanted to calculate the mean, we could go over here to our little auto sum, and in other versions of Excel, it's a little kind of a script F with a little X under it, looks like for a function, and that's the little button that you're looking for to open up some functions. And you can see that these are the kind of the basic functions, and there are more of them for the other ones, but we can do the average, count numbers, right? Min, max, we can do some of those, and then we can find the rest and the more functions. We'll bring those up in a second, but let's just do average. If I click average here, you can see that it defaults to just trying to find any numbers that are near you. So it wants to just add up these cells and give you the average of those, but you don't want that. You want the average of all of these. So you have to scroll all the way down, because remember there's 98 of them, and pick up all 98 of them, and then hit enter, and there's my average. And that's going to be a pain in the butt to highlight those every single time. So what's nice, what you can do, is if you highlight all of your numbers that you're going to be dealing with, highlight your data, and I've already done this. If you go up here and you click on this, you can title it whatever you want. And so call it scores, right? Give it a name of scores. And so now Excel says, okay, I understand now that the range B4 through B101 can be referred to as just scores. So now I'm going to put it here. I know it's not the median, but I want to show you that you do get the same thing. So now I'm going to come down here, and I'm going to go back to creating an average. But instead of averaging up E4, if I go in here and type in scores and hit enter, you see how I get the same number? So it's averaging up those same B4 through B whatever it was, 100, 101 or something like that. Okay, so that's going to make things a lot easier for us. But we don't want to take the average. We want to take the median. And if you don't know what it is, if you just start typing in what you think it is, right? So you do equals and then M, E, and look at that, it brings up median. Double click on that, leave it as scores, hit enter, and there's your median. All right, let's do the mode. So we click in here. See, that's that little FX that I say that's sometimes what this button looks like in different versions of Excel. So now let's type in mode, see what we get. Well, it gives us some different options. Mode multi, mode single, and then the old. Anytime you see this symbol with that little kind of like caution symbol, that means that's an old version of mode. Every time they come up with a new version of Windows, they kind of redo some of the formulas and how they're calculated in Excel to make them a little bit more dynamic, a little bit better. And this is what's happened here. It used to be that all it could do was return a mode, but now they've gotten better where they can figure out if it has multiple modes or not. So if you have the option to choose the multiple mode, that's usually the better way to go. And if you're not sure, you can look right here and see what it tells you this is. The mode.mult version says it returns a vertical array of the most frequently occurring or repetitive values in any array or range of data. It says for a horizontal array, use transpose, blah, blah, blah. All right, so let's double click that one and then put in scores and close it and see what we get. We get 24. So it seems that 24 is our mode. That one showed up more than all the rest. Well, what if we did just the normal mode? Right, we're just going to choose normal mode, see what that gives us. See, it's the same thing. So we don't have multiple modes in this data set. Okay, standard deviation equals ST, and you can see stdev.p.s, standard deviation A. There's a bunch of different versions. Standard deviation.p is if you're going to treat your numbers as a population, P for population, then you would use that one. Since this is a sample, we want standard deviation S, and then again, scores. There's our standard deviation. Max. Scores equals min. Scores equals range. Well, range doesn't come back with what I wanted, so let's back that up. Random doesn't seem to work. R's not giving me what I want. All right, so if that's not working, then go here, click on more functions, and type in what you're looking for. I want range. Hit go, right? And that still doesn't give us what we want, so go to all and hit go. All right, and look what we get. All sorts of weird stuff. None of them seem to say just range. But this is that first one that came up when we did range. And it says returns the probability. That's not at all what we want. Right? So it doesn't look like Excel has a function that calculates range. And the reason why is because it's really super easy to do once you have min and max, right? Because remember, the range is just the distance between min and max. So let's just define it as equals max minus min, and there's our range. Okay, count is we want to know how many things we have. Let me show you something. If you highlight everything, you can see right underneath my cursor, it says 98R times one column. That means I have 98 rows times by one column. That's the data. But you'll also notice that down over here, it gives me the average of those numbers, it counts the numbers, and it sums them up. If you right click on that, you can change what it shows you. Okay, but I know what the count is from here. Let's see if we can get Excel to give it to us as well. So equal count, and there it is. It counts the number of cells in a range. So I can double click on that. I can type in scores, hit enter, and there's my 98 scores. All right, so that's pretty easy to get that right out of Excel. Now, what else can we do with this data? Maybe we want to make a histogram to kind of show us what's going on. We want to have frequencies of all these different data values. Well, we know that our minimum data value is 12 and our maximum is 35. So let's put a 12 in here for our lowest score. And if we drag it, it gives us all 12s. We don't want that. So if we turn this one to a 13, and now we have 12 and 13, and we highlight both of them, now Excel knows that we want a pattern. So instead of just repeating 12, it wants us to count up by 1. And if we drag that now, we get the numbers 12 through 35. Okay, now we want to know how many we have of each of those numbers. So we need to count up in our data how much we have. Now we could take our data and we could order it, right? We could sort it. So for instance, if we took all of this, I'm going to move it because I don't want to sort it where it sits. I want to leave this alone. So I'm going to Control C. I'm going to go over here and just Control V, paste it. And now if I go up here and do A to Z, it's going to sort it from smallest to biggest. And now I can sit here and count. I've got 112, I've got none of these, da, 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 and do it that way. But again, that's going to be kind of tedious. It'd be nice if Excel could do it for us. And it does. It has a nice little count if function, equals count if. And what it does, it counts the number of cells within a range that meet a given criteria. So if we double click on count if, we have to give it a range, and then comma, we have to give it a criteria. And if you don't know how to do this, if you click on that hyperlink, it'll take you out to a Microsoft video that explains count if. So anytime you're dealing with Excel and you don't know how to do a function, just click on the function name and it'll bring that up and show you how to do it. It's pretty cool. The other thing, you can click on range and it'll describe that for you, and criteria, and it'll give you an example. So the range, remember, is scores, and then comma, and we have to tell it what we're looking for. We're looking for it to equal 12. So let's try just typing in 12. All right, let's see what it does. Gave us 112. Okay, that's great, but now I'm going to have to retype that for all of these. So instead of letting it equal 12, how about we let it equal that cell, W2. We still get the same thing. Now if we drag it, let's just check it really quick. We get zeros because we see we have no 13s, no 14s. Let's make sure it works for 15. There's two 15s. All right, looks like it's working pretty well. So now we drag it all the way down, and there are the counts. If you're looking for non-numeric data, so let's say you were searching for count if, how many times the word yes shows up, you would just type in yes. Sometimes, depending on the version, you can't type in yes, you'd have to put it in quotations, just so you know. But for numbers, just type in the numbers. All right, now we've got all of our counts. From there, we can now calculate these cutoffs. Now, we technically didn't need to do this at all. I was just doing this to show you how the count if function works. We could just go straight to this table here, and we want to know how many scores are 18 or less. So we do the same thing. We do a count if function on the scores, comma, but now what we're looking for is in parentheses, right, less than 18. And let it go that way. And then if we want to do this one, less than 22, less than 26, and we could type all of those in each time, but it might be easier to do it as a formula. So instead of having the formula where we're going to type in less than 18, let's just replace that with that cell, because we've already got it typed right there. And you can see we still get 3. And this should still be 14 when we drag it. See, now it's G5, right? And so now if we drag it down, that's still going to be 45. And it goes all the way up to 98. All right, so the frequency for our histogram is going to be these numbers. So let's just drag this. I already defined it as H4. I drag it down, it's going to be wrong. It's going to be 14 and then 45 and so on and so forth. We don't want that. Because these are, right, so less than 22 counts up everything that's less than 22, but it also includes everything that's less than 18. If we want things that are in between 18 and 22, we have to do the difference between them. So that's why we had to have 2 columns. So this number here, you can see, is how many total we have, H5, minus how many we had above it. That's how we define that one, H5 minus H4. Right? And then this one, you can see, is H6 minus H5. We can really just do the difference between those over there. So if we drag this one down, it does it correctly, right? It calculates each as a difference, 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 difference. And then I already created a table that was grabbing this data to create the bars. And so here's our little frequency bar graph that shows how many we have of each of these sets of data. So between 0 and 18, there were this many people who scored it. And if you hover over it, it gives you a value of 3. If you hover over this one, you can see there's 11, and so on and so forth. And you could change it. There's ways to change your table so that it actually labels these. It have a little 3 above there and a little 11 above there. Since these since these categories, these classes, right, don't skip anything. It goes from 18 to 22, then it starts at 22 to 26. It really would make more sense if this was more of a histogram instead of a bar graph. And it's very simple to change that. If you double click on the bar, it should bring up a menu for changing the format of those bars. And what you're looking for is the width of the gap width. And right now it's defaulted up at 219. And if we just drag this down to a lot less, we can see the bars get a lot closer. And in fact, I'd probably drag it all the way down to like 5%, just so you can see a little daylight in between them. And that's everything for this video.